All right, students, looking at a practice problem from the Chapter 6 test, looking at a request for something that was very similar to number 10, just so that way if you guys wanted to see it one more time, you could. I am looking at a problem on page 424, number 16 in your textbook. Says the vertices of PQRS are there in front of you. I have it graphed. And into the directions it show the diagonals are congruent, perpendicular, bisectors. So it's 3 steps. Okay, congruent, perpendicular, bisectors. And if we look on page 422, you'll see that it shows they're congruent, perpendicular, and bisectors. So that is where this is the problem that I had most of you referred to for seeing one that was just like your test. So here's another one. So let's start out with showing that they are congruent to each other. And these are the diagonals. Okay, these are the diagonals. We're going to show PR and QS. So show PR is congruent to QS. So this is going to be the distance formula. So the distance of PR equals, and it's the square root of -4 minus 7. And we're just going to go in and fill in how we would fill out our distance formula. -11 squared plus 5 squared equals, and that's going to be 121 plus 25, which is the square root of 146. Okay, and we don't have to simplify that down the radical. We just need to show that QS is also the square root of 146. That's the important thing. So the distance of QS is the square root of 4 minus -1 squared. That's going to be 5, so that's a good sign. So that's going to match up there. And 3 minus -8 squared, that's 11. We had an 11 up here, so that is a good sign as to us being on the right track. We got 25 plus 1, 21, which is 146. Okay, so we're good to go there. Check that off. Step 1's done. Step 2, they're congruent. Now let's show they're perpendicular. So PR is perpendicular to QS. This is the slope, lowercase m, of PR is going to be -5 minus 0 all over 7 minus -4, which is a -5 over 11. And then the slope of QS, which is -8 minus 3, -1 minus 4, which is -11 over -5, which those both turn into positive. Negative divided by negative is positive. So those are perpendicular to each other, opposite reciprocals. This one's negative, this is positive, and the 11 has been moved to the top, the 5 has been moved to the bottom. So we are good to go on step 2. So remember, we're trying to show these diagonals are congruent, perpendicular, bisectors, which then allows you to say that it is a square. Therefore, it is a rectangle and a rhombus. So now show bisectors. And the last step, just like on page 422, is to show that they bisect each other. We need to show the midpoint, which is capital M of PR. And we have -4 plus 7 divided by 2, and 0 plus -5 divided by 2, which is 3 halves, comma, -5 halves. So if they're bisectors, they're going to have the same exact midpoint. So midpoint of QS equals 4 plus -1 divided by 2, and 3 minus -8 divided by 3 plus -8 divided by 2, and add for midpoint. Therefore, we have 3 halves and -5 halves, which is good to go. Therefore, this is a rectangle, rhombus, and a square. and we showed they are perpendicular, congruent perpendicular bisectors.